There is a range. So a better question is, how often am I within 1% or 2% or 5%? And maybe that tolerance is based on when it starts to become expensive of being wrong.
So that's where these confidence bands come into play.
Yeah, I mean, the 95% confidence interval is a very popular place to start. Hi, everyone. Brian Amrine here with Value-Driven Analytics. So excited to welcome another very special guest on the channel today, Gary Spakes with Ridge Trail Ventures. Gary, it's great to have you here today.
Man, I'm excited to be back again. You know, we've been having some good conversations around the analytic process and the analytics life cycle. And the last time we were together, we talked about data mining and what went on with that, which is part of the predictive analytics space.
Yes.
But there's another big component in the predictive analytics space as well. It's called forecasting.
Yeah.
Analytic techniques that we use in data mining, we don't necessarily use in forecasting as well.
That's right.
So help me understand a little bit about some of the differing problems that you get from data mining versus forecasting, and what do you need in your data to do forecasting?
Yeah, we talked about some of the data mining kind of problems and business use cases that you had last time, predicting things at the customer level, for instance, or getting really granular. You know, what product should we recommend for this customer? Are they likely to buy?
Or what coupon's going to be spitting out at me when I'm at the grocery store when I'm scanning stuff, right?
That's right. But when you think about time series modeling, forecasting at a high level, a lot of times you're predicting, you know, in the coupon example, the high level, like what is our volume going to be for this product for the next coming, maybe it's at a monthly level, quarterly level, sometimes it's down to the daily or even hourly or minute level, but you need to know something. And
okay, so when you're saying forecasting, you're really talking about time.
Yes, a forecast of what is going to happen to a particular metric of interest, any metric you're interested in. What is that going to look like over time in the future?
Okay, right. So what are some of the problems that you see from a forecasting standpoint? I mean, the one that I can just think of is what are sales going to be next month or something like that. But there's other types of problems besides that.
Yeah, absolutely. You might be predicting sales, of course, but you might also be predicting what your profit is even further down the funnel. And there's different ways of, sometimes you almost have like a funnel of starting with sales and then predicting what your profit's going to be, and then predicting what your profit per unit's going to be, and then maybe multiplying those together to get your total profit. But all kinds of things. So maybe predicting the volume of customers that are going to come into a store to help you with staffing. That could be a problem. Not just being about sales from a am I going to hit my sales goal or not, or what is our profitability going to be, but also what are our orders going to be at that kind of stage in the process, so that you can staff your manufacturing team properly to address those orders as well, getting ahead of it. So it's not just for the sake of knowing what sales are and whether you're going to meet your goal, but also for production planning type things. This can be really useful in the supply chain space.
Yeah, and you know, the one of the biggest forecasting things that I can think of is weather. You know, we all see weather on the news all the time, and we live in North Carolina.
Yeah.
So it's not the time of year, but we get these things off the coast in the Atlantic called hurricanes as well, and that's a really good time forecast because they're predicting where these hurricanes go. But when they do that, they throw these bands out that are surrounding the eye of the hurricane. And those are confidence bands, right?
Yeah.
Yeah. So talk to me a little bit about, you know, in not only forecasting weather and looking at the confidence, they're confident that it's going to stay in this range and it could go this way and this way. But what do those confidence bands mean from a forecasting standpoint for some of the use cases that you've talked about?
Well, weather gets a bad rap for you know, always, you know, whatever they say, it's not going to be that, right?
Hey, just got to be 51% right. I'm a great weatherman. Is that what you're telling me? It's going to rain or not? No, kidding.
Honestly, that applies to a lot of use cases, though. If you were to make a forecast, again, for something like sales instead of weather, your model will probably be 0% accurate. It is very rare, especially if it's a large volume and you're predicting millions of units, that your prediction is going to be exactly to the unit accurate, right? So if you're calculating what percentage of the time is what happened exactly what I predicted to the unit? It's probably 0% of the time.
So you're telling me weather didn't get a bad rap.
Exactly. Compared to all the other industries where analytics is applied data science, the same thing happens to those types of use cases too. But there is a range. So a better question is, how often am I within 1% or 2% or 5%? And maybe that tolerance is based on when it starts to become expensive of being wrong.
So that's where these confidence bands come into play.
Yeah. I mean, the 95% confidence interval is a very popular place to start. I'm 95% confident that the range of weather or sales is going to be between this lower limit or this upper limit. That's a great thing to provide. That way you're speaking not just to what they call your kind of final outcome is often called a point estimate out of my best prediction, but you're also providing confidence interval that says the range is going to be between this lower limit, that would be your 2.5 percentile value, and this 97.5 percentile value, that's your 95% confidence interval. So now you can plan around that. Perhaps if you want to be conservative and say, well, I definitely don't want to underproduce because I don't want to miss out on sales. And you would calculate the cost of missing out on a sale to figure out exactly where you'd stop producing, but most likely you might produce a little bit higher than that range to say, well, at least if I produce the upper limit of this 95% confidence range, there's only a 2.5% chance that I'll have sales above that and start missing out on sales.
Got it. So let's dig into this a little bit more. You know, we've talked a little bit on the high level around some of the use cases that forecasting can do, and some of the value that you get around these confidence bands and being able to be in the ballpark, if you will. But when I think back to what we talked about last time with data mining and in the data exploration phase, we talked about target variables and we talked about independent variables.
Yeah.
This seems like a completely different realm that we're in forecasting. Do those concepts, independent variables and target variables, do they apply?
They do apply, but the modeling technique is just a little bit different for them. So
say we're not using like neural networks and decision trees and gradient boosts and those explainable models like linear regressions versus some of those other ones. We're using stuff that's different than those.
Usually not. Now, sometimes your data set can be set up in such a way, and your independent variables can be set up in such a way where you can use those for time series forecasting. But most of the time, you're looking at a completely different brand of models. So all of these, the ones you just mentioned, plus the time series models that we'll probably talk about, both of those still fall under the umbrella of supervised models. They're still a right answer.
Okay, so they're supervised models, which means that they have a target variable and they got independent variables that go along with it, and you're not just throwing them all in a blender to figure out what comes out.
That's right. The non-supervised plus trained grouping exercises, so it's still a supervised model, but usually it's a different type of model, and it's optimized for predicting a variable in the future. And it really comes down to, when you think about time series models, it's taking the seasonality that you've seen in the past, it's taking the trend that you've observed in the past and recently, and using those to predict the values in the future. Trend and seasonality, taking those. Sometimes they bake in residuals as well. How often have things been off from what you would have predicted in the past? And using those to update your predictions as well, to make your prediction, learning from past seasonality and trend.
Okay, so last time we were together, we talked in the data mining side of the house. We were talking about like the coupons that spit out at the grocery store, and you're looking at the transaction that goes across, and you were talking about ice cream and starting to spike in the late spring, early summer months. People are buying more and more ice cream. So if I just took like those data sets that we're talking about there, and I took like the transaction date and I used that, whether it's the month or the day of the week, or maybe even the time. Am I doing it late night or am I doing it early morning and stuff like that? Those things can all play into a forecast.
That's right. The month, like you said, the week, holidays can have a big impact. Sometimes if you need to predict something down to the day level, or sometimes even the month level, holidays shifting from one month to another, that can have an impact. So taking all that into account, plus the trajectory, plus the trend as well, and bringing those together to make a prediction. That is what time series modeling is.
And some of these time series techniques are...
Well, there's a lot of them. So ARIMA, and it has several different versions of it. So if you wanted to consider seasonality as well, you could end up with a SARIMA one. And if you want to add other exogenous variables, like not just with most prediction model, time series prediction models, you're using just that metric's history to make a prediction in the future, stripping out seasonality trend. But sometimes there are certain versions of models that you can include other exogenous variables as well. So if you have a prediction for weather, so ice cream sales, that would basically involve, by default, for most time series models, just using past ice cream values month by month or week by week to predict future ice cream variables. These versions of time series that would include exogenous variables as well, like SARIMAX, would also could bake in other variables as well, like your forecast of weather and how that has historically impacted ice cream sales. So now you're not just using past ice cream sales, but maybe other variables that could also help predict ice cream sales. And there's a lot of ways to do that, but going from like a ARIMA model to a SARIMAX model could be one way of doing that. So ARIMA is a big one, a very popular model. Another one is exponential smoothing, and it has several versions as well. Holt-winters is the version of exponential smoothing that takes into account both seasonality and trend. And it just does that in a different way than ARIMA does. So there's quite a few time series models, and I think it comes back to what we were kind of talking about from a data mining perspective, and those regression and decision tree and random forests, where you might try multiple algorithms and see which one works best on a holdout data set. That concept applies.
So you can actually run a model tournament for time series data as well.
That's right, exactly.
Now, do we have to consider data imputation? We talked about that last time as well. Do we have to consider data imputation for time series? Or
I would say usually that's not an issue, because your sales, as long as you have a complete time series, you usually don't have to worry about missing data. If it's missing, it might mean that you had 0 sales there. If for some reason you did have maybe your system was down for a period and you don't even have, you were never able to restore those sales for that time period, maybe then you look at imputation or imputing values. Now, one very interesting use case where you would impute, not because of missing data, but perhaps a lot of companies saw their historical trends change dramatically when we first had the shutdowns due to COVID in March, April, May, and sometimes beyond. So it's like all of a sudden, in some cases, some companies might have seen a spike in sales, some might have seen a dramatic drop in sales. If you don't account for that and you build your time series on that model, most models are going to assume that, let's just assume like the sales dropped a lot during that time period, right, because of shutdowns. Now all of a sudden your model is predicting every March or April that sales are going to be down again. And unless you expect that to happen all over again, that's probably not your best estimate of what happens. So in that case, there is some imputation you probably want to do before building your time series model, and that is to impute for those values that were dramatically impacted by a shutdown that we hope doesn't happen ever again. You would want to impute a more reasonable estimate of what would have happened then, and then build your time series on that.
Got it.
That's very important.
Got it. So time series modeling, different than data mining modeling, yet still valuable because of what you're looking at across many different time periods that are there from the predictive side out there. That's a lot to take in.
Yeah.
Yeah. Hey, my name's Gary Spakes. I'm from Ridge Trail Ventures, and I've been it's been a pleasure to be on your channel here, Brian.
Pleasure's all mine. Thanks for joining today, Gary, and please consider Ridge Trail for your analytics needs. I'm looking forward to partnering with you, Gary, and it's just been fun to talk about analytics and data science again. If you enjoyed this video, consider liking it. If you'd like to see more, subscribe. See Gary and I talking about analytics some more. See all kinds of analytics training videos.
Comments in the bottom.
Comments, that's right. If you have questions, if you have feedback, please leave it. We're open to feedback. And just Looking forward to seeing you in the next video. Thanks again.